Loeffler? Probably screwed that up.
Chad Loeffler
Okay, great.
from Southwest Research Institute.
Thank you.
So this is going to be a case study on two divisions within SwRI trying to come together and determine what should our coding standards and conventions be. So there are many reasons to have standards and conventions for projects: interoperability, portability, compatibility, consistency, reusability, readability, long-term maintenance, compatibility with static analysis tools, acceptance by customers, and reducing common mistakes. And then here's an example of why we really need standards, so it doesn't end up looking quite like this. So we did a survey between the two divisions in SwRI that currently do flight software mainly. And we found that many projects had their own custom standards, not necessarily external standards, and there was no consistency between the two divisions on which were used, just each project doing their own standard mainly. Many projects were not required by their customer to have a certain particular standard, just that we had a standard on that project, not which one it would be. Many projects found that simply being consistent to a standard also was more important than which standard in particular was being used, just as the project was consistent. And many of our projects really did not have a great way of enforcing the standard or proving to a customer that we really were following it. Standards can be checked through various means such as inspections, reviews, static analysis tools, and editors. Inspections can sometimes be infrequent, and they don't always necessarily provide 100% code coverage when done. Static analysis tools are good, but they don't always support custom standards, and not all of them integrate cleanly in the build process to be run every time there's a compile. Editors are good at sometimes supporting style and formatting checking, but not functionality and performance. And while many of our editors do have the capability of providing style and formatting guidelines or automation, many of us don't quite know how to do that within our editors. Either the editor has it disabled by default, or installing custom plugins aren't always the most straightforward way. We also found that sometimes overly restrictive standards, in the absence of good checking tools and processes, sometimes can lead to more errors than they prevent. They can also be difficult to adhere to and remember if we don't have good enforcement. And like with any tool, it can be used properly or improperly, and a standard that limits too many language features might have us using workarounds which introduce errors of their own. And regarding, say, static analysis tools or infrequent inspections, if they're only done, say, at certain milestones or at the end of a project, then that's going to lessen the likelihood that we're actually going to make substantial changes simply to adhere to that standard that we found we were non-compliant to it. And since there's always the risk of introducing errors for any particular change, and so change just to adhere to something we found at the end isn't always the best. So we said, okay, we're going to look at a couple of different standards here and see if we can figure out, okay, is there something that meets our needs and we can all agree to? So we looked at Joint Strike Fighter, C++, MISRA, Programming Research, and then two from JPL, Powers of 10, and the new one from March 2009. So we said, okay, when we're looking at these standards, they should be easy to use, understand, remember, so we can adhere to it good. They should be suitable and relevant to the applications and processes that we have. Ideally, they would have default inclusion, static analysis tools, or easy plugins for it. They'd be accepted by the industry and ideally be public domain or freely distributable and accessible. Our final two contestants ended up being both from JPL, Powers of 10, and the new standard. So for Powers of 10, there were many things that we liked about it. There were only 10 rules, which would be easy to remember. There was no licensing on it, and the code sonar static analysis tool had support for it. But there are also disadvantages as well. It was deprecated and obsolete, replaced by the new standard. Some of the rules had significant objection by those of us at SwRI, And JPL had fixed those objections within their new standard when incorporating powers of 10 into it. So then we looked at the new standard, and there were many things we did like about it. It fixed everything we did not like about powers of 10. It was much more complete and comprehensive than powers of 10. And it was created by the customer that we saw as most likely to have us required to use their standard in the future. But then for the disadvantages, there were 31 rules, and if there was opposition to saying, well, are we going to remember 10, how are we going to remember 31? It includes 89 non-public MISRA rules, and we weren't sure that there was any static analysis tool that had the 31 custom rules in it by default. So then we kind of had a philosophical divide between going for external standards or going for internal standards. And if we had an external standard, would we follow it 100% or take only pieces of it, thus creating an internal standard? So for external standards, there are many advantages. It's already been created by somebody else, so we're not reinventing something. It's accepted by the industry, and it's being developed and maintained by somebody else, so we're not expending our resources on it. There can be provable compliance through enforcement, such as static analysis tools and plugins to editors and IDEs. Our primary customer is NASA and JPL, so if we pick their standard, then it's probably going to make them happy for that. But then there are disadvantages to external standards as well. They're developed for another organization's applications, processes, and needs, not necessarily our own. They may be too restrictive in certain areas or even already deprecated in certain cases. They may not always be publicly available. It may be a standard that we are begrudgingly accepting as opposed to something that we've agreed is going to be of great benefit to us. Not all of our customers are JPL, so just choosing a JPL standard does not guarantee all of our other customers are going to be happy with what we've chosen. So then we looked at internal standards. Okay, if we have an internal standard, it's custom created to identify and address all of our needs. It'll fit in well with our processes and our applications. And there's a better chance of it being accepted internally because it's one that we've created ourselves and have gotten buy-in from everybody on. But there are disadvantages as well. We may not have the ability to enforce it because we may not be able to configure our editors to support a custom internal standard, nor would we really ever be able to find a static analysis tool to support our internal standards either. They may not be acceptable by our customers. And if we have the ability to freely change our standard, then we're likely going to always be changing it and modifying it. And if there are already standards in existence right now, are we benefiting by adding yet another standard to that list already? So where we've ended up right now is it's still an ongoing process between the two SwRI divisions, and I'm going to have to leave this with a cliffhanger and maybe a part 2 next year on which standard we've actually chosen and why. And so I've added a couple of extra slides here in terms of, we've looked at other languages too, such as Python, TCL, and Java, and we've not formally chosen a standard yet, but for reference, I've included some up here. Python's PEP 8. It's an external standard by the owners of the language, and it's created, maintained, and updated as the language evolves. There is one for, I should say, that we use Python heavily with our GSE equipment, GSUS in particular. TCL is gaining a lot of traction with us since it's used by the Giromon tool, and so we can do a lot of board checkout with TCL as opposed to having onboard software on the board. And there is a TCL standard in existence for it. And then Java is used in a lot of our ground processing software and applications. And there are guides from Oracle, although that one's deprecated now. There is a Google style guide and one from JPL as well. And then there are also some pretty good notes that I've shown here from the Python's PEP 8 guideline. So a style guide is about consistency, and consistency is important within a project, but it's even more important to be consistent within modules and functions within that project. Also, there are times when you may want to be inconsistent, do not break backwards compatibility just to be in compliance with the new standard that was not in effect when the software was written. And some reasons to perhaps ignore standard is when applying that standard would make it less readable. If that would then make it inconsistent with everything else within that particular function or file, there's always the trade-off of, if we adopt a standard, do we go back and refactor and retrofit everything in existence, or do we have some threshold as far as, okay, if we're going to make a major modification, then we have it comply. Otherwise, if there's no other reason to change it, then there's the possibility of introducing an error into it when we do that. Okay, are there any questions? Yes?
I had a general comment because I've worked with the JPL standards that you listed there, and just as you're working through your investigation, keep in mind that C and C++ are not necessarily going to fit some of those standards that are listed for C. And as a use case, last year we ran our project that was built for JPL in C++11, ran it through their static analyzers, something like 500 odd errors, and we're looking at it like, we cannot be that wrong. And it turns out that their static analyzers didn't even know about their rules. They thought they did, but it didn't even know how to deal with C++11. And out of 500 some odd errors, basically one rule actually tripped, which was you shouldn't have more than 60 lines in a method. So take it with a grain of salt that, you know, those rules are going to fit your language. So if you're really working with just C, fantastic. But if you're working with C++, take a look at them and see how they're going to apply. And then there's also some couple ambiguities there with the term of initialization as well that we kind of asked around and got various answers. So that also becomes a project dependent requirement. So.
Thank you very much. That's a lot of good information and good things to think about.
Great. Other questions? I don't see anybody. Okay, great. Oh, another one? Oh.
We were wondering what tools and technologies have you tripped over in actually checking all the rules? Things like LDRA or plugins for IDEs and whatnot.
So right now, within my particular division and my particular group, we've used the PC-Lin static analysis tool, which has been quite great. But we've also found generally with static analysis tools that there can be many false positives. And if we don't run the linting tools right when we start writing the software and we do it at the end, there's sometimes overload with thousands of warning messages. And so we've almost been training ourselves now. So we've managed to get PC-Lin to integrate with our build process. So if there's an error, it's not even going to compile. And so we've trained ourselves almost to write to it and the miserables as we've turned on within it.
Okay, thanks.
Other questions? Yep, sure.
Something probably not in your survey that I've experienced is when creating an internal standard with a panel, some people are willing to die to make sure that the curly brace goes along with the function definition or the line below. So it's a big waste of time. I'm a proponent for finding a standard, accepting it, and maybe tailoring it. But just a little comment there.
I agree. Yes, internally we all have, it can be very easy for everybody to divide into certain camps as to whether, even with spacing, is it 2 spaces, 3 spaces, 4 spaces to replace a tab? Yes.
Okay, thank you. Oh, another one?
You made the point before that it's more important to have a standard. How long have you been debating, and how much longer is the debate going to go on before you simply pick one and say, this is what we're doing, and we have one now?
Very good question. So I'll answer that in 2 parts. So the other division, not mine, in the past they ran their survey and their attempt, I think, It was a couple of years ago, I don't remember exactly when. And I've also heard from those who've been there longer than me that this is not the first time the divisions have tried to come up with a standard everybody could accept, and each time when they've gone down the path of going for an external standard and requiring 100% buy-in, it's always become an abandoned process. So we're hoping that this time we're going to get it right, whichever way it ends up falling out. We started this process probably 6 months ago, and so when I wrote my abstract, I thought we'd be much further along and I'd have much more to present at this point. And so we ended up hitting such a brick wall on the external standard functionality and performance, we've now gone towards style and formatting internal standards for this point.
So just a quick comment for the standards. If you look at the introductions and front material for the standards like MISRA, AUTOSAR, JSF++, they all call out that they applied only to a specific version of the language. So that's also something that should be taken into account. For instance, MISRA C++ only applies to C++ 03, and they do not account for modern C++, whereas AUTOSAR C++ for the automotive industry is taking that into account, and it's actually evolving. You'll see they've taken over in the evolution of MISRA as well. So there's some things happening for the external standards that you should take into account. And keep in mind the external committees are actually doing a lot of work to make sure they keep in sync with the evolution of the languages themselves.
Very good points.
Lots of good questions and comments. Anybody else? Okay, great. Thank you.